So what is a qubit? So let's start from probability. Okay, let's start from probability. P of 0 plus P of 1 is 1. In any system with two outcomes, 0 and 1, their probability must add up to 1. That is basic probability theory. So any physical system must respect this rule. Okay, let me repeat this again. In any system with two outcomes, 0 and 1, their probabilities must add up to 1. That is basic probability theory. So any physical system must respect this rule. Let me introduce the qubit. This is ket. This is called ket. Okay, just ignore the notation. Let's understand the concept first. Okay, a qubit is described by two numbers, alpha and beta. These are called amplitudes. These alpha and beta are called amplitudes. They are not probabilities directly. Okay, then let me write this. Absolute value of alpha square plus the absolute value of beta square is equal to 1. This is the defining equation of a qubit. This is the defining equation of a qubit. Let's understand this with an example. Suppose we have 0.6 and 0.8. Okay, let's square them. 0.6 square is 0.36 and 0.8 square is 0.64. Let's add these. 0.36 plus 0.64 equal to 1. In quantum mechanics, probability is the square of the amplitude. So the probability of measuring 0 is absolute value of alpha square. 0 is here and 1 is this. Okay, and let me repeat this again. So probability of measuring 0 is, the probability of measuring 0 is absolute value of alpha square, which in this case is 36.36, and the absolute value of beta square is 0.64. The probability of measuring 1 is the absolute value of beta square, which is 0.64, which then if sum both of them equals 1. Squaring ensures probability is positive and sums to 1. Okay, let's take another example and understand what is normalization. What is normalization? This is very important. What is normalization? Let's understand this with an example 3 and 4. This cannot represent a qubit yet. If you think like this, represent a qubit. No, this doesn't represent qubit yet. Let's make them. First of all, we square these. 3 square plus 4 square equal to 25. Then we know that total probability must equal 1. Okay, let me write this here, 1. But as we know, 25 is not 1, so we just square root 25, it equals to 5. Then we will divide both numbers by 5. 3 by 5 and 4 by 5. This becomes this. Now let's square them. Okay, let's use these again. Let's square 3 by 5 square and plus 4 by 5 square. Then it will become 9 by 25 plus 16 by 25. Then if we add these, it will become 1. This process is called normalization. we scale the vector, so total probability becomes 1. So a qubit is simply a normalized 2-number vector. The squared magnitude of those number gives probability. That is the mathematical foundation of quantum computing. Okay, let me repeat this. Here, let me write those important points. So qubit is simply a normalized 2-number vector. What is qubit? Normalized 2-number vector, and the square magnitude of those number gives probability. The square magnitude of those numbers gives probabilities. Okay, and if we add both of these, it becomes 1. That is the mathematical foundation of quantum computing. So in the next video, we will answer an important questions. Why are these amplitudes allowed to be complex numbers? Okay, and if you have any doubt, you can just comment and I will try to answer that, and I will bring some questions in the future videos, okay, about this topic. Thank you.